Yeah, let's wait for 2 minutes. Yeah, we can start the session. So, welcome all to this week 8 live question discussion session. So, in this session, we primarily discussing the last year questions. Along with, we are clearing some doubts or any queries related to this week 8 content. And yeah uh, so so this session will definitely help you in solving this year assignment questions. So please carefully attend this session, and also if you have any doubts, silly doubts or any query, don't hesitate to let me know in that case. Okay. Yeah. Yeah, we can start by question one. So this question is related to the vector addition. So let's go to the question, what exactly the question is about. The question one states that consider a vector u with a very high magnitude as compared to a vector v. Okay. So it is saying that, second, vector u has an higher magnitude comparative to the v. Okay. Comment on the direction of the resultant vector when u is added to v. So after u is added to v, v is add, u is added to v, don't the resultant vector, whatever resultant vector you got, suppose uh, w resultant vector you got. So we need to state that what is the direction of that this particular resultant vector w. So okay, so uh, let's see the options here. So it is states the first option is closer to u, closer to v, and third option is that independent of u and v. Okay, so it's not related to u and v. So let's visualize uh, these two vectors. Okay, the first vector, it's at this position, let's assume that, and second one is, and it states that it is comparatively very low, means u is a very high magnitude uh, vector, and v is and lowest magnitude vector. Let's name it as v, u and v. So it's passing from the origin. Okay. So you can see the magnitude means whatever the distance we got from this point to this point, the origin point to the that particular v coordinate. Right. So this magnitude is very high compared to this magnitude. Okay. So yeah, so it is saying that the resultant vector, which is an u plus v. So what could be the direction? It is closer to u, v, or closer to u. As already stated in the v content, so the resultant vector should be, it means after the addition. So you will get the to the near to u actually, near to. So somewhere similar to this location. It depends on that particular v vector. So but it's near to the highest magnitude, which one has an which coordinate has an highest magnitude at that or closer to that particular coordinate, you will get a resultant resultant vector. So this is a w can represent here, maybe. Okay, so this is an some distance. It is an it's not exactly same position at u has u, u is there. So it's not it's depends on the v. When v is added to the means minimum magnitude is added to the highest magnitude, you will get uh, somewhere vector that is near to the highest magnitude vector, which is an u. So here the option is correct, which is an closer to u. This option is correct because u has an highest magnitude actually. You can see here u has an highest magnitude, so that our resultant vector can will get as an closer to u. Yeah, I hope this is clear. It's very simple, which has already discussed in the lectures. Yeah. Okay, let's move to the question two. So the question two states that which of the following statement best describe the concept of hubs and authorities? So the hubs and authorities you have might be understood in the lecture. So let's recall here what is and what exactly the hubs and authorities actually. Yeah. So so we have some recommenders actually. So already let's take as a same example which has covered in the lectures. Uh, so we you have some recommenders, and you are only listening to the your best recommenders, who's your means whatever you are thinking and your best friend thinking is matching. So you are listening means you are suppose you are deciding somewhere something which, or you are going somewhere in some places. So you are trying to approach to that person which has which is your best friend, and his thinking and your thinking is very matching actually. So it importance, that friend is important to you to for taking us some decision or uh, some taking us some recommendations actually, right? So let's take as an suppose you are here actually. Let's take as an one assumption, right? Then we have to combine it these hubs and authorities in a single graph here. So let's draw a bipartite graph. Okay. So let's assume you are here maybe, okay, and here are your recommenders. Okay. There are multiple recommenders are there, and it's not the recommended might be equally important to you, all the recommenders, or there are some recommenders are mostly important to you, like that. Okay. And there are some places, or you can say some foods, right? Let's take as in places, that is an easy to understand, which has already, right? So these are some places, right? So if you are asking to the first node, which is an first recommender, the first recommender will recommend this place and this place, right? If you are asking to the second recommender, she will recommend this place and this place. Likewise, the third recommender will recommend this and this, right? This way, the recommendation will be done, right? So you are asking to these recommenders pointing to the places. So this is an bipartite graph, right? Bipartite graph means what? There are two groups are there, two groups of the nodes are there. There is a node in between the edges, means in this you can assume there is a circle here, right? In that circle there are four nodes are there. In between the four nodes, there is a no edge between there, right? The edges are among the groups, right? So this is the representation of the bipartite graph. Okay. So here you understood which are the recommenders and which are the places. Those are recommending by those nodes, right? So here the recommender act as an hubs, right, which has an some information, right? And here the places uh, act as an authorities. Okay, so this is the nomenclature representation we are considering, as we have considered the recommenders as and places as an example to understand this concept actually. So the hubs provides the information to the authorities, which are of authorities is the uh, best or good for that particular hubs, right? So so in terms of the hubs and authorities, how you can asking the questions? So you are asking to the hubs. There are multiple hubs are there, and you are asking to the hubs. Uh, Please recommend some places, right? So each have hubs and different authorities, right? Different authorities means different places are there, right? So based on this uh, question, the hubs can recommend the authorities to the that person, right? So we have seen this concept separately, right? There is separate representation for the hubs and separate node uh, representation for the authorities, right? So we have to also consider that this in one single graph means that each node act as an two roles. The first role is an hub and second role is an authority. So here we are discussed that each node has act as a single individual role, which is an hubs or authority, right? So let's discuss in a single graph each node how can hubs and authority this role plays, right? So and take here same. So we have a graph. Let's take a one graph. So this is directed graph. Okay. So this node is referring to this node. While he is referring to the another node, he act as an hub. Okay. He act as an a recommender here. Right. And let's take this is also is pointing to this node. Then he's pointing this point likewise. Okay. So you can see here, so when this node is referring to someone, at that time this node act as an hub. Okay. And somewhere, suppose this node, let's take a this node. Okay. So you understood what how the hub is playing a role here actually. If someone if any node is referring to some node, at that time that particular node that this node act as an hub. Okay. So let's take this node. At this time this node is referred by someone. Someone is referring me. At that time this node act as an authority. Okay. Maybe it's confused. Let's take as in this one edge here from this node. So at this time, so here while we are considering this edge, okay, incoming edge to this particular red node, right? At that time, this node represented as an authority. So are you understood how means what is the pattern here actually? So when from the node, when there is an outgoing edges are there, at that time we are considering we are watching his hubs representation, right? And while when we are watching his incoming edges, at that time we are watching as an authority role of that particular node. So if someone has asked you, so what is an how many as an means suppose this node hub is there, how many authorities he or which authorities he referred. So at that time we have to see the outgoing edges, right? Hubs means outgoing edges, right? And someone you want to see or you want to see for a particular node which hubs has referred to that particular node that is an authority. So how much for this authority how much users has uh, recommended this. So at that time we are seeing watching as an authority role. At that time we are watching as an incoming ages. right? Likewise, we are playing a role of hubs and authority. I hope this might be understood. So let's see what exactly the hubs and authorities. Suppose I wanted to calculate the score of that particular hub, or I need to define the hub score for a particular node and authority score for a particular node. At this point of time, you understood maybe how we can consider, or which for the hub, which ages we need to consider, and for the authority role, which ages we need to consider. For the hub calculation or a hub define, we need to consider the outgoing ages, right? And for the authority um, role, we need to consider incoming ages, right? Okay, incoming edges from the hubs, right? That is and hubs are pointing to the authority. So let's read the options here. The first option, which is an authority update authority update role, states that for each page. So here the node represents on one page actually. Okay, that page is recommending some another page. Likewise, okay, each page p update authority. Auth means authority. Okay, authority p is the may update means we are defining a some score or quantifying that particular node or page. Here node is an page, right? And we are calculating or quantifying authority of a particular page. So for quantifying that particular page, what exactly we are doing? The sum of hub scores of all pages that point to it, right? Suppose let's consider this node, right? So it is saying that, so whatever pointing to it, which are the hubs. So here represents hubs, okay, and this blue node represents an authority role. While calculating or defining or quantifying authority value, what it is calculate, what it is considering, it is saying that the first statement is state that the sum of hub score. So these are the hub 1, hub 2, hub 3. They have some score actually, right? Let's take a random score here, okay, and we have to consider their sum of that all the hubs which are pointing to that particular this node. So that is an authority value, authority score. So this statement is actually right, that we are doing in the hub and authority calculation. I will also take one example that means in bipartite graph in the next example. So in that you will clearly understand this concept, right? So the second option states that authority update rule states that for each page p, update or p is the average of hub score. It is saying that we have to take the average of particular this node. It's not like that. Okay, we need to check, and we need to mm, take a summation of all the hubs score which are pointing to that particular node for authority role of calculation or authority quantification. So might be you have cleared the definition part. Actually, we'll take one example in the next question. We'll discuss exactly how uh, the authority score we are calculating. Okay, let's. So have we understood that is an authority score? How we are updating or quantifying? So we are taking the summation of all the hubs which are pointing to that particular node, right? Okay, let's move to the hub update rules, which the third option states that update hub P means hub value, hub quantify, is the sum of authority scores of all pages that is points to the uh, that particular node. So here, imagine like this way. So here, let's take this side. This is a node. The red node here representing a hub, right? And let's take this one. So these are the authority. It's pointing to this recommender, right? So here we have to calculate. It is saying that the sum of authority score. These are the authority node. Okay, it is pointing to that particular hub. Okay. So we are taking the sum of all the authority score of all the pages, that is point to it. So here the same how we have calculated for the authority value. At that authority calculation or quantification, we have considered his uh, incoming ages, which have whose nodes which has a hub. We have submit out their hub score, right? And in the hub calculation, hub quantification, we have considered their authorities scores, which are pointing to them, pointing to it, right? That particular node. So in the last, it is saying that we can take a you can update hub score by by taking a maximum value of authority score of all the pages. Means it is saying that from the neighboring nodes, which are incoming nodes, you can take a maximum score of node, that is, and your updated hub score actually. But it's not like that. In that case, you will only consider only a node which has highest hub score, right? But it's not like that. We have to consider um, all the neighboring nodes, incoming neighboring nodes, because we'll give the importance to all the nodes, right, which are pointing to that particular node. Yeah, yeah. So here the options are correct here, which are for the related to the authority. The first option is correct, which is an summation of the all the hub score which are pointing to that particular node, right? And the last option, for the hub quantification, we have considered the all incoming nodes, summation of all incoming nodes, means summation of all the authority score of all incoming nodes, right? Uh, Sorry, it's not fourth; it's an third option, because in fourth, it is considering only the maximum authority score of all the pages which are pointing to it, right? It's not like that. We are taking as sum of the authority scores. I hope you have cleared this, you have understood this. Yeah, let's move to the question 3. Here, if you have not understood here, you will definitely understand here how we are calculating the hub and authority score, or quantifying it, the hub and authority. So here, as we have considered, taken one bipartite example, right, in the previous one, that this is an left side nodes represented as an recommender, and right side nodes represented as places. So these are the users A, B, C, right? And you are asking to the your friends, these are the your friends E, A, B, C, and ABC is recommending some nodes, that is, in some places P1, P2, P4, and your B friend, which is referring to the P1 place and P3 place, or two places likewise. Okay, so here these nodes act as an authority, right? And mm, this node act as an hub, right? So in a single graph, how the node represents hub and authority role, that we have discussed in the previous question, right? Here we'll discuss how hub score can be calculated and authority score can be means quantified. Right? So let's take an A. So this is an hub. So hub score, how we are calculating it. So whichever it is pointing out, so here you can see it is pointing to the P1. So it is taking the P1 authority score. What is his his value? There isn't some value for this particular P1, right? Particular P2, there isn't some value which represents that how much that place is, and very means, you can say simply it is an ratings, right? Out of 5, how much this P1 has got as an rating. So out of 5, it got as an 3, right? V2 as an P2 as an 4. Likewise, I'm taking just a random example actually, to easy to understand, right? So here that ratings here represents as an authority scores, right? So the for hub quantification, here we are quantifying the hub A by by summation of the authorities, right? So P1 plus P2 plus P3. sorry, P3, not P4. Right. So this is how we are calculating the hub score, or updating the hub score. In each iteration, it get updates in that random graph that we have seen, which has there is no bipartite graph actually, right? There is no two groups are there. There is an randomly edges are split in over the uh, graph, and based on that, it is updating in each iterations. Right? And after the iteration, it gets converged. Right? That we have seen in this week. So for the B, how the B score, hub score we are calculating, which is an B is pointing to the P1 and P3. So P1 plus P3. So for the C hub score, how we are calculating, P2 plus P4. Right. Sorry, there was a very noise from background because there is an Ganesh Utsav is going on in this. Yeah. Right. Yeah, we have calculated here. We are quantified the hub here. Let's quantify the authorities. How we can quantify the authorities here? Right. So here we have four authorities are there: P1, P2, P3, and P4. Right. So P1 is pointed by two hub nodes, right? Which is an incoming nodes. So here, which are the two incoming nodes? Two hubs are there, A and B. Is treated as an hub. So for authority, the P1 represent an authority. We are quantifying here authority here, right? So for a quantifying authority, we are considering the hub score of A and hub score of B. Right. So for P2, two pointed, two hubs are pointed, which is an A plus B. Right. P3 only pointed by the B. Right. P4 pointed by the C plus A. Right. So this is how we are quantifying the hubs and authorities. So let's move to this question. In this explanation itself, the answer of this question is here actually. So what the exactly question states? Let's see. Consider the following bipartite graph. Which of the following is or are correct for the repeated improvement? Right. So repeated improvement means at each iteration, each node gets an update his values, and at a certain point of time, all the nodes in the graph has gets an same values. Means after some iteration, suppose you got as an values, and in the next step you will get the same values. So after that iteration, there is a no changes in the updation actually. Right? So that is an converged points. So here, which options are correct? We need to see. So for A is an authority hub. So how we is calculated, P1 plus P2 plus P4. This is how we are calculated. Right. This is how we are calculated here. So this option is correct. So P3 is an authority. Authority, how is calculated? By taking a summation of all the hubs which are pointing to it. The P3 only pointed by B, so it is also correct, because you can see here only pointed by this. Then C is quantified by only two outgoing edges are there, but it has stated that the four. It's not correct, right? It's not correct. The C option. The fourth option, it is saying that P1 quantified, that is an authority. It is taking the summation of A and B, right? Only 2 points are there. So this option is correct. So option 1, 2, and 3. Fourth. The four options, three options are correct here. Yeah, I hope you have understood this question. Yeah, let's move to the another question, uh, which is a mathematical calculation. Let's see what exactly it is saying. Let C be the unit circle, right? Unit circle means, yeah. Let's unit circle with a 0 0 as its origin in the xy plane. Okay, so let's draw here. Here is x, y, and it is saying that there is an unit circle. That means unit circle means that radius of that particular circle is an one unit, and it the origin or circle center point is passing from uh, the origin of these coordinates x y plane, which is an c. So this is how it represents. The radius is 1. It's not uniformly drawn here, but understand it is, and the radius is 1, and at 1, so this position is also 1, this is also 1, this is also 1, likewise. Okay. So let's see what exactly the question is asking. Then A, the point at which the vector 3 7, right, 3 7 here. Let's take a point 3 7. It on the x-axis, and like exactly y x, right. So it is this is passing on coordinates line, right, and we have to find intersect c. So this line is intersect here, right, so we need to find out this point coordinates, this point coordinates. So how we can find out? Yes, how we can find out this coordinate? So as we are taking as in 3 divided by square root of squares of these coordinates, which is an 3 square plus 7 square. This is an x coordinate, and another is an 7 divided by uh, 3 square plus 7 square. So 3 divided by, yeah, 3 divided by 9 plus 49, and the answer is 58. So here option A is correct. Right. So I hope how we have calculated here. Right. So for the unit vectors, we have taken uh, for each coordinate, we have taken a square root. Means we have normalized the coordinates, which are squashing it in a unit vector. Right. That is that we have used in that matrix multiplication, right? While we are calculating the page rank, which is an one matrix is there, and for that matrix we are multiplying a vector, right? And each time that vector is updated, how we are how the updated means, suppose a matrix is there, okay, and we have multiplied by a vector v, right? We are getting a v1 vector. After second iteration, this is the first iteration. Second iteration, what we are doing, the same matrix we are multiplying by this resultant vector, and before we are multiplying it, we are normalizing this vector in a unit vector, in unit dimension, right? So by while normalizing it, we are using this formula, right? Means we are doing this calculation and applying to that particular vectors, to this vector v1. So we again we got 10, then v2, then we normalize this vector, then we are used in second iteration. So second iteration, likewise v3, we are getting v3. So so on so forth. We are doing this calculation for v1, v2, v3, and at a certain point of time, we are getting as v2 and v3 means vn and vn minus 1 are the same vectors. So that point is an converged point. After that iteration, after those n iteration, there is a no uh, uh, for the subsequent iteration there is a same vectors you will get as a result. Okay. Yeah, there is a too much noise. Maybe what we can do. Yeah. So let's move to the question 5. So the question 5. So the question 5 states that which of the following statement is a true about a Markov matrix. So the for the Markov matrix, we have seen their concept in the lectures also. Uh, we have brushed up that concept as well. So the four option states that option one, all the elements in Markov matrix must be a non-negative, and each column must sum to one. And second option states that a Markov matrix is always a square matrix. It's not necessary. Then third option states that the determinant of Markov matrix is always equal to one. Markov matrix can have negative elements. So here we have already seen, right? Option A is correct here. So all the elements in a Markov matrix be a non-negative, and each column must be equal to one. Let's move to the next question. Which of the following statement are incorrect? Right. So here the statement one states that applying a matrix on its eigenvectors only change the direction of eigenvector. Matrix on its eigenvectors only changes direction of the eigenvectors. So it is saying that suppose we have a matrix and we have applied a vectors, we multiplied with a vectors, and it is stating that you will get a resultant value, resultant vector or any vector only changes the direction of the eigenvector. It's not like that, right? It also changes the dimension, means it's in direction and squash into the smaller space actually, right? Eigenvectors of a matrix are linearly dependent on each other. So exactly, dependent or independent, right? Is an independent. It's not an independent to each other. The eigenvectors, right? So the both options are incorrect here. Okay, let's move to the next question. Given the graph as shown in the uh, following figure, calculating the page rank using matrix multiplication method on this graph, how does the first matrix operation look like? So as we have seen that we are taking a matrix, that matrix represent a graph. Whatever graph we are representing that graph in a matrix format, and then we have multiplying with any random vector, right? Any random vector, vector v, we can consider as, right? And that resultant we are getting as a v1, right? And then we are normalizing this vector v1 is equal to v1. Then this is the first iteration. Second iteration, we are again multiplying a with the v1, right? Then you will get as an v2. V2 is equal to normalization. We are also doing their normalization in V2. Likewise, we are doing iteratively this process, and at some point of time, we will get as an same values for the Vn and Vn minus 1. At that time, we are terminating the iterations. Okay, likewise. So here we have to represent this graph into the first iteration, how it look like. So first prepare a matrix, how the A matrix look like, right? Let's prepare the A matrix. So we have a four nodes, right? Node 1, 2, 3, 4. So here also 1, 2, 3, 4 like this. So let's consider one node. So this is an one node, node number 1. So we have to see how many incoming edges the one is getting it. At the initial, right, so it is getting the incoming edges from the fourth one, and fourth one, as in though there is a no multiple outgoing edges are there in the fourth one, means there is an full values of whatever the uh, values at four number node, whole values are transferred to the one no number one node. Okay, so whole values are getting rid the number, other values are 0 bits, because from other nodes it is not getting a incoming edges from for the node number 1, right? So it getting in 0. Let's take as a second number node. So second number node also getting as an incoming edge from the one node, node number 1, right? But you can see here, node number 1 has an node number has an two outgoing edges. That means whatever his score or whatever he has any value, that is distributed equally in between these edges, right? Suppose it is an distributed half here and distributed half here, likewise. Okay, so the half of the value of number 1 node, it gets to the number 2 node. That means here the value, it's we are getting as an 1 1 divided by 2. Right, 1 divided by 2. So there is a no other incoming edges are there at position at no number 2, right? So there are 0. This is an also 0. Okay, let's move to the node number 3. So here, node number 3 has an uh, 3 has in two incoming edges. The first one, second one, right? So that is incoming edge from the 2 and incoming edge from node number 1, node number 2 and node number 2. You can see here node number 2 has also two outgoing edges, means whatever his contribution, whatever his value is equally distributed in this node and this node, one half, right? So at the three number node number 3, you will get a contribution from first node, which is 1 by 2, second node, no, node number 2 is 1 by 2, because two incoming edges are there and other values are 0, right? Likewise, for the fourth node number 4, the two incoming edges are there. So from the third node, node number 3 and node number 2, as already said that the node number two outgoing edges are there, means two equally their value is distributed equally in between the two edges. So the half contribution of the number 2 nodes is going, and the 3 node, there is a no multiple outgoing edges are there, only outgoing edges is 1. So the whole contribution is gets to the fourth. So here 1 by 2 and 1. So from the node 2, greater than 1 by 2, and from node 3, it the is getting 1, 0. So this is an A matrix here, right? So this is represented first iteration, the first initial state of the calculation. While matrix multiplication, for calculating the page time, we are considering this matrix. Let's see it is incorrect or not. Let's compare it. Which one is correct? 2 0 0 1.2. Yeah, this option is correct, right? Option A, right? Option is correct, and these are the common values. So you can see these are the initial values are there. So the whatever the values or whatever the information is equally distributed among the all the four nodes, right? So option A is correct here. Let's move to the question 8. Here we let's say it is about the authority and hub. Uh, this question is. So let's read what exactly the question states that what is the score value of authority? Right. So question 8 states that what is the score value of authority A and hub H respectively for the node 4. So we have to calculate it, the authority score for the node 4 in the following figure after applying one step hub authority computation. So we did not need to calculate the repetitive updation of the authority and hub score. Only at the first step, what is the hub score and authority score of node number 4, right? The k, when k is 1, k means how many repetition, how many updation we are doing. So here updation we are doing at as one, only one step. Assume initial hub and authority of each node is 1, right? So it is stating that I already we have already discussed in the previous example. There is an for each node that we have discussed in a random graph like this way, this graph, the node, each node act as a role, act two roles, hub role and authority role. And how we have calculated the hub and authority role, that we have stated from one question, right? The hub score we have calculated by summing it the authority score of his neighboring nodes which are pointing to that particular node. And authority score we are calculating by incoming nodes hub score, by we are summing that particular scores. So it might be somehow difficult to understand by theoretical statement. Let's do it by experimentally how we can calculate it, that how node score um, in a graph. Yeah, let's see, Jyoti. Yeah, which option is correct here? So the for the fourth, as we have states that for the hub we have to consider the outgoing edges. So there is an outgoing edges only one. So for the hub, for one step, hub score for one step is an one, right? Because only one outgoing edges are there. Only one place it is recommending. The fourth node is an recommending fifth place. Likewise, you can understand, right? And it is pointed by, and at the time of the authority wins authority step one. For the calculation we need to see how many incoming edges are there, right? So here incoming edges are the three incoming edges, means for authority calculation it act as a place. So how many recommenders is recommending me, right? You can see three recommenders are recommending me. So at that time I need to see what is his what is third node hub score, the one node hub score and second node hub score. So it is in 1 1 1, right? 1 plus 1 plus 1 is in 3. So option 2 is correct here. Yeah, third and right. Yeah, right, Jyoti. Yeah. This option is correct, B option. Yeah. Let's move to the another question. So it is about a page rank calculation by using the matrix multiplication, or we can put the values in the Excel sheet and let's see what exactly how the node values are updating. So what exactly the question say? Well, let's see what values of page rank will the nodes A, B, C, D, E. 5 nodes are there of the given graph. How after the second iteration, means we need to find after the second iteration what is the value of each node. If the initial values are 1 by 5 for each node. So for this two question, we share my uh, laptop screen. Yeah, I hope the screen is visible, right? Okay. Yeah. So where we have to, where the seat is. So let's see the what. Okay, I will also share this screen as well because I hope two screens are visible, right? Let's first define how the A, B, C, D, E values are updated at each iteration. So we have to quantify by his incoming and outgoing ages. Likewise, in previous example, we have drawn and or constructed a matrix, right? That matrix A based on the graph. Likewise, we need to consider, we need to write expressions for this each node. So for updating, which nodes are contributing to A, that is in C nodes. But you can see C has in three outgoing edges. So C divided by 3, right? So this value will be goes to the A. Then only in one incoming edges are there for the A. Let's move to the B. B has two incoming edges. You can see here. B has two incoming edges from the A. A is not divided. There is no outgoing edges, two outgoing edges from the A. So we are directly considering whole value of A and another edge which is an E. But you can see here E has two outgoing edges, this one and this one. So E is distributed equally here, E by 2, right? So B is updated by two edges, so two values are there, E and E divided by 2. Let's move to the C. So C has got as an only one incoming edge, which is from the B. But you can see B does not have an greater than two outgoing edges. So we will directly consider B as an update value here. B directly here. Whole B value is assigned to the C. Then how we are updating D value? So you can see we are getting the two incoming edges from the D for the D. So from the E and C, but C is divided among the three. So C divided by 3 and E is divided among the two edges, outgoing edges, right? So we are getting as an plus E divided by 2, right? Then E. If I am going somewhere wrong, please let me know, okay? Yeah. So E, you can see here there are two incoming edges are there. This one and this one, from D and from C. From D there is no more than two outgoing edges, so we can directly take D value here. But second incoming edges which has an C divided by 3. So we have taken. I hope this is an correct intuition, correct expressions. Right. Is there any mistakes here? I hope there is no mistakes are there. Yeah. Let's move to our Excel sheet. I hope my screen is visible to you. That Excel sheet. This is right. Hmm. So yeah. So let's put the values here. So we have four coordinates: A, B, capital C, D, E. This is simple. I already covered in the lecture, but for the simplicity, I will also cover in this session as well. So if you have any doubts or any query, please let me know. Okay. So initially it is states that initially the all the nodes has an values 1 divided by 5. So 1 divided by 5 divided by 5 I am taking here. Make more zoom. Okay. Yeah, maybe this is visible too. Okay. So then, so this value is same for all the nodes. So I have dragged all. Then at so how the a value is updating. So a is and c divided by 3. So this is in c node, right? Divided by 3. So c 3, right? This is how much we are getting the value. So b is the value from a plus e divided by 2. E divided by 2. E by 2, right? Then c is directly b, and d is c divided by 3, c by 3, and plus e divided by 2, right? So here d plus c divided by 3. So these are the value you can say. Yeah, these values are updated, you can see. So this is a second iteration values. So these are the second iteration values we got. Okay, as 0.33. It is converged or not converged? Let's see it is converged at which point or not. Means converged or not, and if it is converged, then at which point it is converged, that we can see here. So at this position you can see the nth row means here 19th row, and minus 1 which is an 18th row. It's not similar, but it is similar, but it's near about, the values are near about to each other. Okay, but it's not exactly the similar. You can see 28, 21, 21, 21, 21. But your decimal, their decimal values are the different, means they're different values. So let's go ahead. 3, still not their last values are, but the initial values you can see here, the correct at the fourth or fifth digits are similar. But let's move to the further. Still not. Yeah, you can see here from the at 7th fifth row, 75th row, you can see from it all the values, all every decimal values are equal, right? So this is an converged point, right? From this there is no iterations are required. Okay, at this point of time the graph is converged. These values are fixed. Each node has contributed these values only, means the page rank, right? How much? So here you can see the 28, the fourth node has an highest page rank, page value. It is an highest important node, we can say that. Okay, and the least important node is and e, which is an less or which has pointed by uh, it's not good node, you can see here. Let's move to the that how we can copy. Let's see, the a has a very low page rank, right? So you can see here. So a has pointed by c, but C is not important. C has their whole the value has a distributed among the three nodes, right? And one of that particular contribution, third contribution has gone to the A. So A value has drowned, right? And we have seen highest page rank value for a node is which is an E, right? And E, you can see E is pointed by multiple nodes. The D, C, right? D and C has an highest weightage is getting, right? So D is third, this second and third, it is getting to E. D whole contribution to the E and C by 3. Likewise. Here A has a little contribution, means at the point of B. So why the B's value is not greater than the E or equal to E? Because A is actually has a less value, right? And it is contributing to E by 2. Here it is an D has an whole values contributed to the particular E. And we are getting E is a first important and is the last one important node. Let's move to the last question. So for this also, we'll calculate this in Excel file. Okay. One second. Yeah. So first of all, we need to draw a matrix A, which has already discussed that we have to multiply a graph matrix, which is the matrix created from a graph, and each value represents how much that particular node is contributing to that particular row node. Like likewise means 1 by 2 1, that one means whole contribution is whole values are passing through that particular node. Likewise, okay. And we are multiplying that particular matrix to a random vector, and we are doing that resultant vector, then we are multiplying that on to the original matrix. Then this process is repeatedly we are doing, and at certain point of time we are getting an converged vector, right? Converged vector which represent our page ranks of each values, each node. Okay. So let's draw a matrix here for this graph. So let's first read what exactly the question is asking about. Assume that assume that the current page rank values of A, B, C are zero point 0.2, zero point 0.4, and zero point 0.4 respectively. What will be their page rank values after convergence? It is saying that there is an initial values are there, page rank values are there. Means initially the scores has defined to each node, which node has the highest, that is, and it is giving zero point 0.2, which is a less page rank value to the point to node 1, and likewise the values are assigned after some iterations. Or what is a convergence value means after some updation you have done. So we have to do this in Excel as well. But first, before that, we need to quantify that which node contributing to which node and how much it is contributing, right? So for that, we need to uh, draw write expressions here as well. Okay. So this expression represents that is a matrix, right? Right. So here A represents means, so let's take another meaning. A, B, and C means 1 by 3. Like D means 0, E 0. Likewise. So this is how we can write an expression, and for that we can draw a matrix as well by doing this as well. Okay. I hope you understood. Right? Yeah. So let's write the expression for one. So let's take as an A, this is an B node, and this is an C node. Okay. So for A node, how many incoming edges are coming? Incoming edges are only one, third node, right? third node. But third node has an only one outgoing edges. So whole B value means B value has contributing to the A node. Right? There is no more than two outgoing edges are there, right? So let's move to the second oh, sorry. So this nomenclature is B C. This so A is getting from C whole C, right? Then B is calculated by A, but you can see A has an two outgoing edges. So the whole contribution of A is equally divided by between these two edges, two outgoing edges, right? Means 1 by 2 here, 1 by 2 here, likewise. So we have considered A divided by 1 by 2. Sorry, what I am writing. A divided by 2, right? Only one incoming edges is going there to A, 2. C has an two incoming edges from A divided by 2, and B from there is a whole contribution goes to the B, goes from, comes from B. So is it correct? I hope it is correct. Based on this, we'll get as an value. Let's revise it. The A has coming incoming edge from the C node, and which has only one outgoing edge. So C has fully contributed. B has B has an one incoming edges which come from A. A has an two outgoing edges which is equally distributed, which is an 1 by 2. So we get as an A divided by 2 contribution, and C has in two incoming edges, which is from A node and B node. From the A we are getting as an half of the contribution from the A, which is A divided by 2 plus B whole contribution. Yeah, it's correct. Let's move to the Excel sheet. Should I should I write here, or okay, I will create a new question 10. Question 10. So we have three nodes A, B, C. B, C. So firstly, the A has zero point 0.2 contribution, B has zero point 0.4, C has zero point 0.4 initial page rank values. Okay, so zero point 0.2, zero point 0.4, zero point 0.4, A, B, C, right? So the A value is the C whole value. Oh, right. And B value is A divided by 2. C value is C value is A divided by 2. A divided by 2 plus B whole B. I hope it is correct. This is an I3. I3 means C, and B A divided by 2, which is an G3 divided by 2, and G3 means sorry, G3, right? G3 means A divided by 2, and B means H3, right? So let's copy this to the next row, and let's draw for couple of. So we are getting very different values. Let's see. So you can see only the last two values we need to see is matching or not. You can see it's near about near about closer to each other. You can see 0.4, 0.39 means there is an uh, in next some steps you will get a converged points. Let's see on, it is getting near to each other, but and yeah, you can see here at 67th iteration we are getting as an converged point. Here is an converged point. This is an converged point. Okay, this is an converged point. Okay, so after this you can see the all the values are getting same, right here. Sorry, it is very, might be it's not visible to you. I will because this screen is very, so yeah, sorry. Yeah, I will explain again because it's not visible to you guys. So you can see here we have uh, uh, right and ABC2 coordinates, and we have given initial values which is point 2, point 4, point 4, and then we have written their expression here. I3, I3 means it is NC, right? And it is B means G3 divided by 2, right? G3 means A divided by 2, right? From the graph we have quantified these expressions, right? And then we repeatedly applied, and we got an after some iteration we got an converged values which are the point 4, point 2, point 4. This is the conversion point at 66 iterations after the 66. So here the option is correct, which is an point 4, point 2, point 4, which is an option 2. Option 2 is correct here. List. Here option 2 is correct. Okay. Yeah, I hope whatever we have considered or discussed in this lecture, that you have understood. And if you have any doubts or any issue, any silly doubts, if you have, please let me know. Yeah, while discussing the questions, we have also brushed up the some concepts which are the page rank, how we are calculating the page rank, quantifying by mathematically, and also we have seen the concepts of the hubs and authorities. What is an hub's role and what is an authority's role, that we have discussed. How we have calculating the or updating the hub value and authority value, that we have also discussed. The definition of the hubs and authority, that we have also discussed. Okay. Yeah. Yeah, thank you. That's all for this session. Let's meet for in the next week. Yeah, thank you. You may leave this meeting.